starting a new chapter today. Thank you for your hard work on your quiz, test, whatever you want to call it from yesterday. You will get them, thank you. You will get them back on Monday. I'm almost finished with all of my classes. I'm just going to pass them all back on the same day. So far, they're looking great. Okay, so in chapter 8, we are going to start with functions. Now, you don't have to go reading all of that, but take a look here. Have you seen a function table? Have you seen something like this before? Okay, if you haven't, let me tell you about it. And if you have, let me tell you more about it. Eyes up here. This is a function table, the whole thing. I'm going to quiz you on the vocabulary on the next slide, or in 2 slides, I mean. Okay, or a couple, I'm not even really sure. Here we go. Now, some things to notice about a function table is this is the input value. Okay, the input value is also known as X majority of the time. And the input value is also known, listen, as the independent variable. Because what's happening here is the input value is going into this thing right here that we call a rule, and then it's going to come out of the machine as the output. Okay, so we're plugging 10 in for X. So 10 plus 7 equals 17. So the input values are also known as independent. We'll talk about, I'll show you the dictionary definition of that in just a second. The output values, what do you think those are also known as? So when when I'm specifically talking about the fact that input is independent, what do you think the output is? Yeah, I'm looking for a vocabulary. Also look up there. And no, huh? Yes, right here. Okay, the output value is also known as dependent. Let's think about what those words mean by looking here. Okay, the independent variable, I like this one right here, not depending on anything else, essentially. The independent variable doesn't depend on anything else. You can put whatever you want in there. So on the flip side, after it goes through the rule, we have the y-axis, or not axis, excuse me. The y values are the output is your dependent variable, and that means it's contingent on or determined by. So it depends on something else. Does that make sense? Okay. So my question is, what does the output, why is that dependent? What I just told you about this, what makes the output the dependent variable? What does it depend on? Go ahead. Good, it depends on the rule and also what else? Yeah, the input. Very good job. It's important that you know this is the independent variable or the input, the rule, and then the output depends on those things. So it is dependent. Okay. Let's go over here to the right. I just want you to acknowledge, look at here. This is also a function table. It's just a horizontal function table. This is also a function table. What's the difference between this vertical function table and this vertical function table? I know it's kind of small over there. What do you see? What's the difference there? What's the difference between that vertical, the bottom one, and then this? Yes? Tell me more. Yes, so what's the vocabulary word for this part? It doesn't have the rule, right? The function rule. Yep, this is your rule. That's important to know. You're exactly right, but those are all still function tables. Okay, let's take a look here. Okay, we're going to relate this to the function tables that you just learned about. You don't need to be writing or doing anything. I just need you to watch up here for not very much longer, and you'll get to do some, I promise. Okay? What is our rule in this function table? A toaster. Okay, so connect this with, if you put toast into, bread into a toaster, what is your output? It's toast, okay? Now, that is your dependent variable. It depends if you get toast, because if you put toast in the microwave, are you going to get toast? You're going to get a warm, maybe soggy piece of bread. Do you see how the output is dependent? Okay? If you put chocolate chip waffles frozen in there, and what comes out of it, your warm, yes, your much tastier waffles than the frozen ones. And then up here, the same thing with a bagel. You put a bagel into a toaster, and I suppose you get a toasted bagel, right? In my last class, they asked, why does toast have a different name, but not like a toasted waffle or a toasted bagel? I don't know. My advice is make it up. Make a new name for it. I don't know. Okay, yeah, make a new word up. That's fun. Okay, moving on. Looking here. Looking here. Do you have that connection of the fact that this is your input, you put it into the rule, and then you get your output? Do you see the connection? That's really, really important. Okay? Let's test your vocabulary now. Okay, what is this whole thing called? What's this called, everybody? Good, it's called a function table. I didn't mean to do that. What is this input value also known as? Independent variable. Good, or independent is fine. Okay, it's important that you know input's also referenced with an X. Okay, what is the output values also? Dependent variables. And what is the vocabulary word? Rule. Good. Rule or function rule. Good. Okay, whoops. Let's go here. Okay, now we should read this. It says the output is 7 more than the input. Do you see how writing algebraic expressions, they just did that to get the rule? You will have to do that as well. 7 more than the input, x plus 7. Do you connect that? Okay, good. So to complete this function table, you simply plug it in, put it through the rule. So you need to replace the x with whatever that row's input is. So what is it? 10 plus 7 equals, just like we talked on the other one. When you are filling in, you don't ever leave the x in here. You're plugging it in and solving. So the x in the second row is 12 plus 7 equals 19, and so on. Does that make sense? Take a look here. Look here. What does it mean, reminder, when there's a number right next to a variable? Multiplication. So you have to write it 3 times, and what is the x in the first row? 0 equals 0. I'm very glad no one said 3, but I wanted to review that just in case. Sometimes that one's easy to forget. Okay, so the next one, 3 times, what is x? Equals 6. So you're putting it through the machine, through that rule, to get the output. Okay, what is different? I'm going to move this up. What's different? Raise your hand. What's different about this one on the board? Yeah. Yes, they gave us the output instead of the input. So this next thing is going to look really familiar to you. We just did it on Tuesday with a reason. Well, and we did it like the whole chapter 7 as well. Solving equations. Watch. Okay, I know this is the same thing as with work half the time I tell you. I know that you could look at this and tell me what the input is. What is the input? 2, because you know that 3 times 2 equals 6, right? Now, I know, you just showed me, you proved it. I know you can figure that out without work. But you must follow these steps because we're going to get into more steps in 2 steps where it's not as easy, and it's so much easier to make a mistake when you don't show your work. So we are going to use this. We have our rule, 3x equals what? 6, your output. And we're trying to figure out what x equals. So we're trying to get what by itself right here? What are we trying to get by itself? The variable, the x. So the opposite of times 3 is divided by 3, divided by 3, x equals 2. Do you see? Does this look familiar to you? It should. It should. Okay. The rule equals the output. I'm not going to do another one there. You'll get some opportunities in a second. Let's look here. I'm just going to do one more of these together, and not the whole thing, but then you will do some yourself. Number C. So how do I know how to solve this? You always have to ask yourself, what information does it give you? Yes. Yes, we have to find the inputs because it gives us the output, and he said we have to use the train tracks. I like that because we have to get the variable by itself. So the rule 2x minus 1 equals what? 1. So does this look familiar? Solving two-step equations. Okay, train tracks, what do I work with first? The 2x? Yeah, the constant. Good. The 1 without the variable. So the opposite or inverse of minus 1 is plus 1. What you do to one side, you must do to the other side. Cross off what cancels. 2x equals. Is the variable by itself yet? No, you have to do the train tracks again. The inverse of times 2 is divide by 2, x equals 1. So you got the input, remember, is x. So x is 1. You might ask, what do I write in that middle section? Watch up here, please leave your book. You'll get to do it in a second, I promise. You just are filling it in and making sure you're correct. Talk yourself through it. So 2 times 1 minus 1. 2 times 1 is 2, minus 1 is 1. So we were correct. Do you understand? The rule equals the output. So please help me write, I'm not going to solve, but help me write my equation for the second row. Who can do that to help me find the input? Help me write the equation for the second row. Please don't be writing on the tables. That's disrespectful. Yes, go ahead. Good. So the rule, 2x minus 1, and then equals your output 3, and then solve. Please go to page 581 and do C and D. I'm going to be walking around and checking them. Okay, finish C and you'll do D. The page number is in the top right if you missed it, 581. And listen, remember, you must show work. We're using the backward strategy. Use your work off to or your space off to the side. You must show work. What? Do you have a question? No? Okay, go ahead. Since I saw a bunch of yours, I'm not going to go through all of these, but I am going to do a couple. So please put your pencil down for a moment and watch. Pencil down for a moment and watch and check in, and then we'll move on. So we already did one example over here. Looking at D, we have the output. So we have to use the backward strategy because we have to put it through the rule and go backwards to get the input. Okay, so 3x plus 2 equals what? 17. Train tracks, the opposite or inverse of plus 2 is minus 2. Cross off what cancels. 3x equals 15. Is the variable all by itself yet? No. So we have to draw train tracks again. The opposite of multiplying by 3 is divide by 3. So 15 divided by 3 equals 5. So x equals 5. That's your input value. This is 5. Now when you're checking your answer with that middle section, up here please. Thank you. You have to fill it in and check it in your head. So 3 times 5, which is your x value, is 15 plus 2 is 17. So you were correct. Does that make sense? Do you want me to or need me to go through one more? Nod your head. Doesn't matter. If I see one head nod yes, I'm going to. Because if you do, someone does. I'm going to do one more. Watch. It's okay. Even if you said no, you still need it. Okay? The second one, or the second row. Thank you. Who can help me write my equation here? Pencils down and eyes up here to be respectful. Thank you. Yes, ma'am. Good. So the rule, and then the second output equals 20. Okay? Get the variable by itself. We have to work with the constant first, the number without a variable. The inverse of plus 2 is minus 2, cross off what cancels, bring down what's left, 18. It's not by itself yet, so we have to divide by 3, divide by 3, x equals 6. So that is your input value. And we should always double check ourselves by plugging it in. So 3 times 6 is 18 plus 2 is 20. We were correct. Any questions? Okay. Now please quickly flip to page 585. And do number, I think it's 15 or 14. I can't remember off the top of my head. 15. Please, it'll take you about 30 seconds. Do number 15. Now, what information does this function table give us? Who can raise their hand and tell me? Yes? No, I'm sorry. You're right. That you're explaining the rule, but what information is on the table? It always gives us there you go. The input. Good. Now this time it gave us the input. So do I have to work backwards? No, I'm just putting it through the rule to have it spit out an output. So we don't have to use backward strategy. We don't have to use inverse operations or train tracks. You're plugging it in. Now watch, I saw this on a couple. Do not leave the X in that middle column. You're replacing it with the X value. So 4 times 1 is 4, plus 2 is 6. So you're plugging in 3 for X this time. 4 times 3, and then the rest of it. So is 12, plus 2 is 14. And now we're plugging in 6 for X. 4 times 6 is 24, plus 2 is 26. It's important that you look at what information is given before you think about how you need to solve it. Okay? Last one, pencils. Down for a second, actually. You don't need to write anything. Last problem we're going through. Follow along. If you want to follow along on page 582, you can. You don't need to write anything, but if you want to follow along on there with your eyes instead of up here, you can. Brianna bikes 12 miles per hour. The function rule that represents this situation is 12x. Okay, my question to you, if she bikes 12 miles per hour and the function rule that represents this is 12x, what is the x representing? Kind of like when we define our variable. What is the x representing? Perfect. The hours, and the x is the input value, right? X is representing the hours. Okay, you have to read very carefully. Let's keep reading. Where X is the number of hours, good. Make a table to find how many hours she has biked when she has gone 12, 36, and 48 miles. My question is, if the X is hours, and if the rule is 12 miles for each hour, what does Y, the output, represent? Yeah, the total miles. It's really important to jot those notes down to know what the X value is representing and what the Y value is representing. So now, where should I put 12, 36, and 48 on this function table? Raise your hand. Where should I put those? Yeah. In the output. How did you know that? Exactly. Look at the label, miles. Does that make sense? If you put it in the input, would you complete this function table correctly? No. So now we have to use the backward strategy to, I'm going to move this down for a minute, to complete the table. So the rule, 12x equals what? What's the first one? 12. Train tracks, divide by 12, divide by 12, x equals 1. So what does that 1 mean? 1 hour and how many miles? Yep, so 12 miles in 1 hour. Good. So the next one is the rule, 12x equals 36, divide by 12, divide by 12, x equals 3. So what does this row mean? Yep, 36 miles in 3 hours. And then the last one is going to be 4. Good. Not a bad idea to fill in that middle row too, to check your work. Now it says, then graph the function. It's important to look at this graph The x-axis is labeled hours. I need your attention up here. This is all going to snowball. Every detail I talk about is important because you'll have a situation that works with it where you have to do it on your own. Up here, please. Stop playing with things. The x-axis is labeled hours. The y-axis is labeled distance or miles. How can I use that function table over there to graph? Raise your hand. How can I use that function table to graph? Yeah. Exactly. So he said the input, we have to look at the x-axis because it's labeled hours. So if I go over to 1, how many miles did I go in 1 hour? 12, so somewhere between 10 and 15. If I have 3 hours, how many miles did I go? 36, somewhere right above 35. And then if I go 4 miles, 48, somewhere between 45 and 50. Do you comprehend that? Okay, your ordered pair is right here, x value, y value. So this is 1, 12, 3, 36. You don't have to label these, but I just want you to connect 4, 48. It's not a bad idea to label them when we don't have exact numbers on the x-axis or y-axis. Okay? Do you have questions about this? Not one question. Are we positive? Okay, so saying that, please open your book to page 583. You might actually already be there. 583. Your assignment is 1 through 7 right there. You can tear it out. Okay, you can tear it out. You're going to tear out page 583 and 586. Nope. Well, I mean, it's attached, I think, maybe. I don't know if it is or not, actually. But 583 and 586. If you look at the top of my board up here, your assignment is right there. 583, number 1 through 7. 586, numbers 22 through 25.